Hello, dear students. All these days I was just keeping quiet. I did not go to do any videos because you had your exam, and after that, we were told that on Monday classes will start. So I just didn't bother to do any video lessons. But you see, again, 1 week, I don't know how many days they are postponing. So I want you to complete that. I wanted you to complete the 2.5 exercise of Pythagoras theorem. So Pythagoras theorem we have done, and we have done the worked examples also. And exercise 2.5, I had told you some problems you can do actually with the help of the book. And wherever for Pythagoras theorem means wherever there will be right angle triangle, you have to use the Pythagoras property. That's all. It is quite easy. I don't know how far you have done now. Already there are 17 sums in that exercise 2.5, and of course some optional problems. Optional problems, at least those who are a bit who can do problems, means who are good in maths, they can try and do optional sums. And others, at least I want you to complete 17 sums, exercise 2.5. But suppose now you have done it without understanding, and you have done just without thinking and all. Then in that case, I just want to show you some problems again. See, for example, the fourth one, exercise 2.5. Exercise 2.5 of similarity of triangles. I won't do in detail. I'll just tell. That's all. ABC is an isosceles triangle, right angled at C. Prove that AB squared is equal to 2AC squared. It's a very easy sum. So you should do the figure, and ABC is an isosceles triangle, and two sides are equal. You know that. And then prove that AB squared is equal to 2AC squared. So right angled at C they have given. So the figure you have to just I had just shown you here ABC to show that it's an isosceles triangle, but now it should be right angled at C they have given. So right angle at C, and ACB will be the triangle there. So which two sides will be equal? If C is the right angle there, then these two sides will be equal. AC and BC will be equal in this figure. I hope you can see the figure there. And then they are asking you to prove here that AB squared is equal to 2AC squared. So just you have to use the Pythagoras property here, because it's a right angle triangle. You see, proof is hypotenuse is AB there, so AB squared equal to, naturally you will write the formula AC squared plus BC squared. You will write. But you know that they have a triangle ABC is an isosceles triangle they have given, no? So AC is equal to BC you will write there AC equal to BC. So what will happen is, instead of AC you can write BC, or instead of BC you can write AC. Any one you can do. So AB squared equal to, I will write here, what we want now, 2AC squared we want. Okay. To prove that they have given 2AC squared. That means you have to write that BC as AC only, because both of them are equal to each other. Therefore, I will do the same now. In the above step, I will write AC squared. I have got already one AC squared I have already got. BC squared I will change it to AC squared, because BC is equal to AC. So what will you get now? You will just get 2AC squared. So easy problem it is. So I hope you have done it. So this is the way to do it. And then fifth one, it is just the opposite of that. Opposite. So ABC is an isosceles triangle with AC is equal to BC there. With AC equal to BC. So same figure. But here what they have given is, in this problem, they have given that AB squared is equal to 2AC squared. See just the opposite of that previous problem. So AB squared is equal to 2AC squared given. So what you should do, you have to go back to the steps. 2AC squared means you should write AC squared plus AC squared. Anyway, it is 2AC squared, so you can split it. You can write AC squared plus AC squared. And then what you can do is, you know that AC is equal to BC. So 1 AC squared, no, you just write it BC squared. So BC squared plus AC squared you get, and that is equal to AB squared. So anyway, if you get like this, then that means what is the meaning? You have got the square on the one side, that is AB, the hypotenuse, means one side you should take like that, because this problem is depending upon the converse of Pythagoras theorem. So you have got AB squared equal to BC squared plus AC squared, no? So that means the meaning is the angle between BC and AC will be 90 degrees and AB will be the hypotenuse there. When you get like this, the meaning is that only AB will be the hypotenuse there. So I have drawn the figure here, that figure is suitable for this what we got here now. So AB squared is equal to BC squared plus AC squared. Therefore, the meaning is angle ACB is equal to 90 degrees, because the angle contained by the other two sides will be 90 degrees. Because it follows the Pythagoras property, this should happen according to the converse of Pythagoras theorem. So that is over, that's over. Very easy, just they are just opposite. Then sixth one, I am just revising, that's all what you have done. I think you have done now the full exercise. I had told you the other day, you have to do up to 17 and then think of some of you can do the optional problems. I told you there are some there, and optional problems is nothing but all right angle triangles you have to use. But still, if you don't get, you can ask me. Yeah, but and also you have got that PDF there, so you can take the help of it and then sit and practice at home. Okay, ABC is an equilateral triangle of side 2A they have given. So I hope you have understood that while doing, you have done, or you might have seen the PDF. Find each of its altitudes. So altitudes means it's nothing but perpendicular or the height. So this is an equilateral triangle. So equilateral triangles, please see the figure. All three sides are equal to each other. Okay, so all three sides are equal to each other and all are equal to 2A they have given. So 2A, BC also will be 2A, but we have drawn one altitude there. It is true for in case of all altitudes. Find each of the altitudes. If you say no, it will be equal. Altitudes will be equal, equilateral triangle. And on the same line, that altitude line only, it can be, of course, altitude means perpendicular it is, and that line, same line will be the median there. It can be the angular bisector, and all those lines will be on the same line, means all these perpendicular bisectors, perpendicular, then median, everything is on the same line. In case of equilateral triangle, not in any other. In case of equilateral triangle, it happens so. Now 2A means when AD is the altitude means height means perpendicular. So 90 degrees angle is formed here. And when this is 2A, you can split this as A and A, because it will bisect also. It is perpendicular bisector also, I have told you. Just now I told you. So what is the meaning there? BD is equal to CD also. Now find each of its altitudes they have given. Now say this is a right angle triangle, and we need something, some formula like for the altitude. Okay, now let us take any one right angle triangle. So to prove that, to find altitude. So altitude you are going to find here, that is AD is how much you are going to find. Now proof, I told you in case of this, in this chapter, mainly Pythagoras theorem the exercise everything depends upon the Pythagoras property. Right angle triangles will be there. So similarly, you have got now here a right angle triangle ADB. So in right angle triangle ADB, in right angle triangle ADB, see what happens. AB squared is equal to AD squared plus BD squared. And then see, AD squared is, we don't know it. But AB squared we know, it is 2A the whole squared. We can put, and BD means it is A. So A the whole squared. We have splitted A and A, you know that. You have understood. So A squared. Now what happens? 4A squared minus A squared. This is equal to AD squared. So what you get here? 3A squared is equal to AD squared. Therefore, AD will be equal to square root of 3A squared, which is equal to root 3 into A. Because A squared, I can remove it out. I can remove it from the square root sign because it is square already, A squared. So, what is the square root of A squared? A. And root 3 will remain as it is. So, AD is equal to root 3 into A. That is the answer. So, find each of its altitude. So, that is the root 3 into A. And sometimes there may be another problem there, in which some problem there. What will be the area of the equilateral triangle? Equilateral triangle area will be area of equilateral triangle. Even this is just because it is a triangle, the area of it will be half base into height. Main formula is that only, but we come across now after substituting everything. See, half into base is 2A in this case. Height is root 3 into A. Okay. So what happens here? According to this problem, suppose they ask you area, I told you, area of equilateral triangle, half base into height. So half into 2A into root 3A. So what happens? 2 will cancel, and you get here, according to this problem I am talking about, root 3A squared. Suppose they ask, I told you. So half base into height. Height is root 3 into A. We have just found here now. That you have to substitute. Base is 2A. You know that. So half into 2A into root 3 into A. So you get like this. Okay. But this is according to this problem. Otherwise, the area of an equilateral triangle is, we are going to prove somewhere, and you have done this in 9th standard. Area of an equilateral triangle. You need this for some chapter in future. So area of an equilateral triangle, it is of course half the base into height, but finally you will get it as root 3 into A squared by 4. Root 3 into A squared by 4 if the side is A. In that problem it was take the side as 2A they had told, but here it is just A. So the area of an equilateral triangle, if the side of the equilateral triangle is given as just A, then the formula will be root 3 into A squared by 4. This you have to remember, where A is the side there. And height of it will be, altitude will be root 3A by 2. It will be actually. So this is just an equilateral triangle whose side is A, just A. You will get this. Okay, now like this you have to try the other sums I told you. I hope you have tried everything, and now when I am doing, you will again it will be a sort of revision. But of course I have to see to the time of the video now. It is nearing the 14 minutes. So I will stop now and go to and do in the next video.